Post and lintel architecture is really pretty simple. Vertical columns, posts, support horizontal beams, lintels. If the first requirement of a building is to not fall down, then post and lintel mechanics require that the columns, the posts, be strong enough to support this upper weight. If the weight above increases, well, then the number of columns must increase, or the size of the columns must increase, or both. You can easily see how at some point the upper weight would be supported by so many large columns that the unobstructed interior space would literally vanish. Post and lintel architecture is a style of construction and architecture that has been used for millennia. The Egyptians used massive stone pillars in many of their temples. The sheer size and quantity of the columns communicated a feeling of being in a sacred forest. Unobstructed space was not an issue. In order to support large weights and overcome the forces of gravitational thrust, post and lintel columns are usually wider at the base than near the top. The horizontal arrows in this illustration, for example, are actually the same size, indicating this phenomenon. Further north, also on the Mediterranean, the Greeks adapted the post and lintel styles of the Egyptians and over time developed three elegant, graceful styles: the Doric, Ionic, and Corinthian. Greek column orders are distinguished by the top of the column, the capital. The Doric is plain, the Ionic has scrollwork, and the Corinthian is embellished with leaves. Here we see the most famous Greek building, the Parthenon, with its Doric style. The Doric columns of the Temple of Hephaestus are visible here. This Ionic temple features the scrollwork. The ancient Romans adopted the Greek style, although they most preferred the Corinthian order and its decorative approach. In this most famous Roman building, the Pantheon, we see that. Traditionally, stone posts were constructed of separate segments stacked one on top of another, as this fallen Greek Corinthian column shows. They were held together by gravity and a central pin which limited lateral motion. These Greek orders have carried on in our day in buildings like the Nelson Atkins Art Museum in Kansas City, or the Chicago Art Institute, or in government buildings like the United States Department of Agriculture in Washington, D.C., or the Illinois State Capitol building in Springfield.